This is the lesson 9.1 and 9.2 notes combined on scatter plots and lines of fit. The first key idea is that a scatter plot is a plot that shows the relationship between two data sets. So when you were comparing data sets in CODAP, you were looking at scatter plots amongst others. That was one of the plots that you could start with. The two sets of data are graphed as ordered pairs in a coordinate plane. And so in this first example where we're interpreting, the scatter plot at the left shows the amounts of fat in grams and the numbers of calories in 12 restaurant sandwiches, right? So there are 12 little dots comparing the number of fat grams and the number of calories. And notice on the y-axis that there's that little break. So instead of starting at 0, we're going to start at 300 and then number by 50s, right? So to read a scatter plot, I'll ask a question like, how many calories are in the sandwich that contains 17 grams of fat? So I'm going to go over to the 17, and I'm going to kind of come up. Okay, there's that point, and then I come back to the y-axis where I've got calories, and it is 400 calories. And we can go the other direction too. Now we want to know how many grams of fat are in the sandwich that contains 600 calories. So let's go up to 600 and then go over to this sandwich. And that is 30 grams of fat. And it looks to me like there is another sandwich that is really close to 600 calories that has even more, has 40 grams of fat. But this is the one that has exactly 600. All right. And then they'll ask for kind of a trend. What happens to the number of calories as the number of grams of fat increases? So I can see that as the number of grams of fat increases, my number of calories seems to be increasing too. If I look at the data, it generally seems to be going upward. It has a positive slope. So as fat increases, calories increase. Say, there's not a line yet. We're going to get to the line of fit in just a second. All right, so the line goes up from left to right. Okay, and then there's one you try there. A sandwich has 650 calories. Based on this scatter plot, how many grams of fat would you expect that sandwich to have? All right. So this little visual is really probably the most important part of this set of notes. A scatter plot can show that a relationship exists between two data sets. So there are 4 different relationships that we'll look at. First could be a positive linear relationship. So you can see that the data is going up from left to right. So it's like a positive slope, and it generally looks like a line. The points lie close to a line, and as x increases, the y also increases. So it's going up positively. You can also have a negative linear relationship. These lines these points also lie close to a line, but this time that line is going down. As the x increases, the y decreases. So if we were to draw a line, it would have a negative slope. Okay. Then sometimes you have a curved line. This is a nonlinear relationship. Sometimes kids get confused and they will say that it doesn't show a relationship. It does show a relationship, it's just not a line. We'll call that relationship a pattern. Because if we were writing the expression or the rule, we would be able to write a rule for that curve. So it's still a pattern, but it's not linear. It's not a line. Right? And then we have the last one where the dots are just every which way and they don't show a pattern. So when you see a scatter plot like that, it really doesn't show a relationship. So when you were investigating the mammals data in CODAP, you saw relationships that were generally linear, although maybe not quite this perfect. You saw some relationships that were negative linear. I don't know if we saw any relationships like this, but we will in some other problems that we're working. And you saw lots of things that didn't show a relationship, even when that data was kind of surprising, things that we thought would be related but weren't. Right? And I'm going to throw in another word here that's not in this set. We're going to call this correlation. Correlation means it has a relationship. I'm going to call that a linear relationship. So this has a positive correlation and this has a negative correlation. All right, we'll use that word. I think somebody used that word in our presentations today. Okay, in example 2, we are identifying the different relationships. So we'll be using the words here to talk about these graphs. So we're going to describe the relationship between the data and identify any outliers and gaps and clusters. So in the first graph, where we are comparing television size and price, we can see that generally the data seems to be going up in a positive linear relationship. So say it generally shows a positive linear relationship. Whoops, left out linear. Okay, what else does it ask for? It asks for outliers and gaps and clusters. So I can see that there's a cluster of data here. So there is a cluster, let's call that a cluster of television prices that are less than $500. Okay, and then there's kind of a gap. So you've got a bunch of TVs that cost less than 500, and then there's this kind of gap here, right? So gap between like $500 to $1,500. Why did I do that? 5 to 1,500. And then there's a piece of data that just doesn't seem to fit at all right there. That outlier, where a TV is a 70-inch television and costs, looks like about 22. So it's at 70 inches, and that looks like about 2,250. So we would expect a 70-inch TV to cost a whole lot more than that, right? If this data is linear, then we would expect this 70-inch TV to cost a whole lot more. It is a whole lot less than we would expect. It's an outlier. An outlier is a piece of data that does not fit with the rest of the data. Mhm. Okay, so then let's look at graph B, where we've got the relationship between a person's age and the number of pets that they own. And when I look at that, it's just kind of scattered everywhere. There doesn't really seem to be a relationship. Sometimes old people have one pet, but then there's also 30-year-olds who have no pets. Okay, so data shows no, let's see, no relationship. Okay, you like how there's no you tries? Okay, and then we move into the next set. The next key idea is about a line of fit. A line of fit is a line drawn on the scatter plot. You try to get it close to most of the data points. So there's a little bit of kind of guess and check to kind of fit the most data. And it can be used to estimate data on a graph. So once you have a line of fit, then you can use it to predict or to estimate. So we have this graph that shows the depth of a river in X months after the monsoon season ends, right? And so X is going to be months, and our Y data is the depth in feet around here. Okay. And isn't it handy that they use such nice numbers? So my months are going up by 1, of course. Let's start there. 1, 2. All right. And then my depth, the biggest depth is at 20, and I think this is a 10 by 10 grid, so I can number by twos. Okay. And then we just need to plot points. So 0 months after the end of the monsoon season, the water is at its highest at 20 feet. Then 1 month later, it's at 19 feet. 2 months later, it's at 15. At 3 months, 13. 4, 11. 5, 10. 6, 8. 7, 7. And 8, 5. Okay. And then there's a certain amount of kind of guessing around to find exactly where you want to draw your line of fit. But we can see that that data makes a pretty clear negative correlation or a negative linear relationship. So as time goes by, the water level goes down, which makes sense. All right. So you kind of feel around for where you could draw a line. I want to include my y-intercept. That's an important point to include. And I've got a couple of data points that cross right at lattice point. So let's see what it looks like if it goes through there. It's nice that the ruler is clear so we can kind of see. So if I draw that line there, I've got 1 point above, 2, 3 points above the line, and 1, 2, 3 points below the line, and I've got 3 points right on the line. So that's a pretty good line of fit, right? You'll also hear the word line of best fit. There, you can use a graphing calculator to find the mathematical line that best fits your data, and that would be a particular answer. When we're finding a line of fit, there can be a little bit of wiggle room in there. All right, the line that I'm going to draw is going to go from 20, and it's going to go through this line at 6 and this or point at 6 and point at 8. Okay, so now I have made a scatter plot and I've drawn a line of fit and I chose it so that I have 1, 2, 3 points above and 1, 2, 3 points below, and I have 3 points that are right on. So it's a pretty good one. All right, so now we have to write an equation. Oh no, what do I need to write an equation? Y equals mx plus b. Well, I know what b is. That's the y-intercept. So let's put in 20. And I need a slope. So the slope is the change in the y over the change in the x. And it's very handy to use these 2 points that are nice points on the lattice. So from this y value at 10 to this y value at 8. Let's see. Let's put down the points that we're going to use. We're going to use 5, 10, and this point 6, 8. Now here's the thing, because you chose, you're kind of got your little wiggle room in there. If you had drawn your line in a different place, you might be using different points on that line to find your slope, and your slope might be a little bit different than someone else who drew their line in a different place. All right, so again, a line of fit is not perfect the way a line of best fit is. Right? Those just happen to be some nice points to use for the example, right? So the change in the y value is going down 2 from 10 to 8, and the change in the x value is going up 1 from 5 to 6. So the slope is negative 2. So I can write in y equals negative 2x plus 20. Okay. So interpreting the slope and the y-intercept, that means telling what it means. Let's do the y-intercept. At 0 months, or right at the end of the season, the river is 20 feet deep. Okay, so that's the y-intercept. Okay. The slope is negative 2, and when we interpret that slope, it means that every month the water goes down 2 feet. The slope is negative 2, so it's going down 2 feet. And then the real power of data is being able to predict. If we collect data on the temperature every year, and you notice that the data seems to be going up and up and up, that can help you predict that we have a problem with climate change, right? And it can help you to predict what the temperature might be in 20 years or 50 years. And it gives us time to make some changes, right? So the real power in data is getting to represent it in a way that helps us to predict and in a way that helps us to make changes. Okay? So to predict the depth in month 9, we just go across to 9. I'm going to switch pens. We go over to 9 and up to here. And I can see that that is 2 feet. So 9, 2. Okay. And that's it. I love line graphing. I love scatter plots.